So let's continue learning about applications with trigonometry. Okay, so we know the formula to find the area of a triangle. We know that to be that the area is equal to 1/2 the base times the height. Now, there's a problem if we look at the triangle right below it. There's no way that I know what the height is. I know what a base is, but I don't know what the height. So we have to think about this a little bit different. So if I have an angle measure and I have the lengths of two of my sides, then I can figure it out. And this is by using sine. So we know that based on this triangle here, if I have A, B, and C as my vertices, then I have alpha, beta, gamma inside. And across, you see side lengths A, B, and C. So that's important to keep in mind that we're going across. So I can find out that the area, so I'm going to use A for area, is equal to 1/2, just like before, the other two side lengths, so we'll call it B and C, and then we multiply it by the sine of alpha. So what we're doing here is we're multiplying this side length times the one that's right next to it and doing the sine of the angle right here. So we can actually write it three different ways, because what if I have beta? Well, I would do 1/2 of the two side lengths next to it, so A and C, times the sine of beta. Or if I had gamma, I would do 1/2 the two side lengths that are next to each other and multiply by the sine of gamma. So it just depends which one you have. So let's look at this example on the right. Find the area of triangle ABC. Well, I'm given this angle right here is 33, and I'm given the two sides right next to each other. So what we're going to do is we're going to set up an equation. I know that the area is equal to the multiplication of the two sides times the sine of the angle that's inside. So that's going to be 10 times 6 times the sine of 33. What did I forget? I forgot the 1/2. So we have to make sure that we remember that we're still including that 1/2 all the way down. So that means that area is equal to, well, 1/2 times 10 is 5, and 5 times 6 is 30. Sine of 33. So now I'm calculator ready. I can go ahead and plug this into my calculator, and we're going to get something like 16.34 inches squared. We don't want to forget our units. So if we're talking about units of inches, then my area better be inches squared. Okay, so now what I want to do is I want to find the exact length here of ST. And I don't have a right triangle. I have three angles and none of them are right, so I can't just do sine, cosine, or tangent. So this is where this idea of the law of sines comes in. It has to do a lot with similar triangles, and so the law of sines is really helpful. It tells us that in any triangle, I have that the sine of alpha over the side length of A is equal to the sine of beta over the length of B, and that's equal to the sine of gamma all over the side length of C. So I can think about this in my triangle. So if I have alpha, beta, gamma, and I have my side lengths here, those are my vertices, excuse me. Across from each vertex is the side length of the lowercase letter. So I do the sine of alpha divided by the side that's across from it. Sine of beta divided by the beta, or the B, excuse me, and then sine of gamma divided by C. You can also write it a different way, so it would be just flipped. So the side length divided by the sine of alpha is equal to B divided by the sine of beta. Let's rewrite that. And then C divided by sine of gamma. So let's use this idea over here on the left-hand side with ST. So I know that I have something here. I have this angle measure and I have this side length. I have this angle measure and I need this side length. Even though I have this side length or this angle measure here, I don't know anything about over here. So we're not going to use the 75 at all. We're going to focus on these two angle measures and these two sides. So based on what I know about the law of sines, I can say that the sine of 45 degrees divided by 10, because that is across from the 45, has to be equal to the sine of 65 degrees divided by x. And now we just have to solve for x. So I multiply both sides by x. So I have multiplied by x on both sides. These x's go away. So x times the sine of 45 all over 10 is equal to the sine of 65. We can move that 10 by multiplying both sides. So I have 10 times the sine of 65. And then lastly, we're dividing, so 10 times the sine of 65 all over the sine of 45. And those signs don't cancel, and we cannot reduce the 65 and 45. So ultimately what we see here is I can plug this into my calculator, and ultimately I'm going to get something around this. So x is equal to 5 root 6 meters. Okay, and that's what we want. We have meters. We want meters here. So let's figure out exactly how we can get that. Okay, so now let's think back to our special right triangles, which are over here on the right-hand side. We have 45, 45, 90 triangles and 30, 60, 90 triangles. Now let's think about how to find the sine and cosine of some of the most useful degree measures, so 0, 30, 45, 60, and 90. So a sine of 0 is always just going to be 0, and the sine of 90 will always be 1, okay? So now let's think about in between. So sine of 30. So if I'm sitting here at 30 degrees, sine is going to be opposite over hypotenuse. So x divided by 2x. So let's see, that's x divided by 2x. Well, that simplifies to just half. Well, that's good. What about 45? I'm over here at 45, and I'm sitting here. It doesn't really matter where you're sitting. And it's x divided by x root 2. Well, we know that that can't happen, so we rationalize, and we get the square root of 2 over 2. Well, that's awesome. All right, and then 60, we know that we're sitting over here, so that means that we're x root 3 over 2x. So that's root 3 over 2, right? Because root 3, oops, excuse me, x is in the wrong spot. We know that just goes down to root 3 over 2. So the cosine, we talked about this before, that if I'm sitting in one spot, the sine of one thing is the cosine of the other one, okay? So if we think about that, cosine of 0, that's always going to be 1, and sine of 90 is always going to be 0. So let's think about the other ones. So cosine of 30, I'm hanging out right here. Cosine is adjacent over hypotenuse. So x root 3 divided by 2x, we did that right here, so it happens to be root 3 over 2. 45, well, we're sitting right there. It doesn't really matter which one we're sitting at. We have this one and this one, so it's x divided by x root 2, which we did right here. It happens to be square root of 2 over 2. And then cosine of 60, I know that I'm hanging out right here, so adjacent over hypotenuse, so x divided by 2x. Hey, look at that. We did it right here. It's 1/2. Okay, so what do you notice here? Well, I notice that the sine of 0 is the cosine of 90, that the sine of 30 is the cosine of 60. So these things will always be true. So this is something that you're definitely going to want to remember and be able to refer to, because these will be used the most in our class. So we can actually go back, if we wanted to the previous problem, and when we were figuring out, and we had something like x equals 10 times the sine of 60 divided by the sine of 45, so this is from that previous problem, we're able to do this a little bit better. So we have 10 times, well, let's see, the sine of 60, I know what that is, because I just found that out. The sine of 60 is this guy right here. So I can replace sine of 60 with that, because we know that it equals that. So that would be square root of 3 over 2, divided by the sine of 45, which we found out is the square root of 2 over 2. So now we can simplify this. We can see that this is the same thing as 5 root 3 divided by square root of 2 over 2. And then we know that we keep switch flip. So 5 root 3 times 2. And then when you rationalize, those 2's cancel, so we get 5 radical 6. And that's exactly how I got 5 radical 6 on the first page. So in exactly the same way that we did on the previous page with sine and cosine of 0, 30, 45, 60, and 90 degrees, we can do the exact same thing with tangent. We find out that we get tangent of 0 being 0, tangent of 30 is root 3 over 3. We get the tangent of 45 being 1, and we get the tangent of 60 just being the square root of 3, and then the tangent of 90 happens to be undefined. So there's no way that we can do the tangent of 90. So if you try to do that in your calculator, you'll get an error. So keep going with this idea. So let's see if we can figure out what the length of AB is, and AB is right here. Now, I need to find a side length. So this is a little bit different than the last one. We don't have 2 degrees, so we can't do the law of sines. So we have this law of cosines. So the law of cosines looks a lot like the Pythagorean theorem, but it's a little bit different. So if I have this triangle, and we'll call it A, B, C, so we have alpha, beta, gamma, A, B, C. So we can first figure out the length of C. So C squared is equal to A squared plus B squared minus, this is where it differs, 2 times A times B times the cosine of gamma, okay? So if we wanted to do this for A, we could do A squared is equal to B squared plus C squared minus 2BC times the sine of alpha. Lastly, we could do it for B squared. We have A squared plus C squared minus 2AC sine of beta. The important thing to keep in mind is that whatever you're looking for over here is that angle over here. The other 2 sides are in here, so that's the important thing to keep in mind. So if we look over here on the left side where we were trying to find AB, we can do this. So I'm trying to find AB, so that's this side right here. So I'm going to say C squared is equal to, I square both of my sides and add them together just like the Pythagorean theorem, and I subtract 2 times the multiplication of those sides. Then I'm multiplying it by the cosine of that angle measure that I have, so the cosine of 30. So we have that C squared is equal to 16 plus, we know 4 root 3 squared, the square goes to both things, so that's 16 times 3 or 48. Minus, well that's 8 times 4 is 32 root 3, and then if we think back to what we know about the cosine of 30, we know that the cosine of 30 is the square root of 3 over 2. So we have C squared is equal to 16 plus 48 minus, well that's 32 root 3 times root 3 all over 2 to combine that, and we know that 32 divided by 2 is 16, and square root of 3 times the square root of 3 is 3. So we have C squared equals 16 plus 48 minus 16 times 3, which again is 48. So we know that those cancel, and we're just left with 16. So C is equal to 4. So that's how we can find the length. It's a little bit tedious, but I know we can do it. So this is a good list of when to use the law of sines versus the law of cosines. So if you have 2 sides and a non-included angle, or 2 angles and a non-included side, we can use the law of sines to do that. And again, let's think about the law of sines as the sine of alpha over the side length is equal to the sine of beta over b, which is also equal to the sine of gamma over c. Law of cosines, if we have 3 sides and need to find any angle, or if we have 2 sides with an included angle and want to find the remaining side. And again, we can think about what the law of cosines are, and that's a little bit different. So that's C squared is equal to A squared plus B squared minus 2AB times the cosine of gamma. or b squared is equal to a squared plus c squared minus 2ac times the cosine of beta, and then lastly a squared is equal to b squared plus c squared minus 2bc times the cosine of alpha. So here are two examples. We know some information. We know that b, so that's over here, is equal to 12. We know that c over here is equal to 10, and that beta is equal to 83 degrees. Okay, so we can set this up. So I know that we'll say that this is gamma, not beta, and we're going to find beta. It's not going to change anything. Okay, so we have that the sine of 83 divided by 10 is equal to the sine of beta over 12. And we know that because we have two sides and a non-included angle, right? So we can do the law of sines. So we end up getting 12 times the sine of 83 over 10, and that equals the sine of beta. So when we plug this into our calculator, we end up getting that the sine of beta is equal to 0.8271. And then using our knowledge, we know that beta is equal to the inverse sine of 0.8271. So that tells me that beta is about 56 degrees. Now over here on the other side, we know that we have acute triangle ABC, find b to the nearest degree. So I know I have a side length here I know, a side length here I know, and I need to find that angle. And so we know that I have three side lengths that I know, and so I can use the law of cosines. So we know that b squared is equal to a squared plus c squared minus 2ac times the cosine of beta. So we know some information. So this is b because it's across from b, this is a, and this is c. So I know that 36, because that's 6 squared, is equal to 16 plus 25 minus 2 times 4 times 5 times the cosine of beta. So I can start simplifying all this out. So I have 36 equals 16 plus 25 minus 40 cosine of beta. So let's kind of move everything over. So 36 minus 16 minus 25 equals the negative 40 cosine of beta. Cosine of beta ends up being 5 over 40. So, which is the same thing as 1/8. So we do that beta is equal to the inverse cosine of 1/8, meaning that beta is approximately 83 degrees. Okay, so the design of series swing set includes two metal posts that support the top bar that each measure 8 feet. At ground level, the posts are to be 6 feet apart. At one angle should the two posts be secured. So first we need to draw a picture. We have two metal posts that are coming down, so like 1 and 2. They're both 8 feet. We know that they're 6 feet apart, and I need to know this measure right here of theta. So we've drawn a picture. Now we have to figure out, am I using law of sines or cosines? And since I know all of the measurements, it's going to be law of cosines. So now we're going to solve it. So it doesn't really matter what you use. We'll just use a squared is equal to b squared plus c squared minus 2bc times the cosine of alpha. And so we're going to call this up here, instead of it being theta, we'll call it alpha, so we just have to plug in. So the important thing to remember is that the angle that we're using has to be across from the one that's over here. So these two have to be across from each other. So 36 is equal to 64 plus 64 minus 2 times, well, b times c would be 64 cosine of alpha. So we end up getting 36 is equal to 128 minus 128 cosine of x, or theta, or alpha, excuse me, but we know that those don't cancel, so we have to subtract 128 from both sides. So I get that negative 92 is equal to the cosine of alpha. Okay, that's not right. We know that negative 92 is equal to negative 128 cosine of alpha. So we get 92 over 128 is equal to cosine of alpha, and again, alpha is equal to the inverse cosine of 92 over 128. So we get alpha to be about 44 degrees.